This hearing will come to order. Good morning to all of you who have assembled here. I want to begin by welcoming all of our witnesses to today's hearing. This morning we will be examining NASA's Space Shuttle and International Space programs. I think it's appropriate that we consider both of these programs at the same hearing, since the shuttle and station activities are tightly coupled and issues affecting one program can have a direct impact on the other. As we all know, NASA successfully completed a shuttle mission to the ISS last month, and another shuttle mission to the ISS is scheduled for early next month. And by all accounts, last month's STS-117 flight was a very challenging ISS mission, one of the hardest parts of the station's assembly phase. And it is clearly a testament to the skill of the entire NASA team that they've made ISS in orbit look relatively easy, when the reality is that it's anything but easy. So in that spirit, I want to congratulate you, Mr. Gerstenmaier, on last month's success and wish you well on next month's mission. NASA also is preparing for next year's shuttle mission to service the Hubble Space Telescope. Many of us were very concerned when that servicing mission was canceled by the previous NASA administrator, and I'm pleased that it is back on the shuttle manifest. We all look forward to hearing about its status at today's hearing as well. However, assembling the ISS and servicing Hubble are only two of the challenges that NASA will need to address over the next several years in its human spaceflight programs. Space Shuttle is scheduled to be retired upon the completion of the ISS at the end of this decade, and there are a great many issues that will need to be addressed during this transition period, and dealing with workforce concerns is clearly an important one. This subcommittee held an initial hearing on NASA's workforce in May, and I anticipate that we will examine NASA's plans for the shuttle workforce, including its legislative proposals, in greater detail at another hearing later this year. Another area of great concern is how the ISS will be supported logistically once the shuttle is retired. It's not yet clear that NASA's budget for logistical support of the station is sufficient for the task, or that all of the planned capabilities will be available when needed. I hope that today's hearing will shed some light on the situation. Yet all of the work being done to assemble the station and support it logistically is not meant to be an end in itself. Rather, it's the degree to which it's utilized productively that will determine the ultimate success or failure of the ISS. That's why a number of us have been so concerned about the severe cutbacks in NASA's space station research program and budget over the past several years. Those cuts have largely decimated the research community that had planned to use the station, with potentially serious implications for the productivity of the station as a research facility once it's assembled. In addition, NASA has yet to develop a well-defined research program for the station that contains clear milestones, prioritized research objectives and experiments, and resource requirements. We all understand that funding is tight and that funding for the station research has to compete with other NASA priorities. However, the nation has invested substantial funds over many years to develop and build the station, and the NASA team represented by Mr. Gerstenmaier has worked hard to make the station a reality. It seems to me that we need to ensure that the nation gets an adequate return on that investment. We have a great many issues to cover at today's hearing. And again, I want to welcome our witnesses, and I look forward to your testimony. The chair now, with a great pleasure, recognizes Mr. Feeney, the ranking member, for his opening statement.
Well, thank you. Thank you, Chairman, for holding today's important hearing on the Space Shuttle and International Space Station, where we will examine the interrelationships between these programs and gain insight about supporting and operating the ISS in the post-shuttle era. As you know, Mr. Chairman, many of my constituents at Kennedy Space Center prepare space station components and the Space Shuttle for launch. I appreciate the fact that you're considering holding a hearing later this year to examine NASA's shuttle to constellation transition planning, which is very important in my district as well as many other areas that are interested in space. I look forward to working with you on this hearing. We can't repeat past mistakes, like the Apollo to shuttle transition, where America frittered away hard-earned spacefaring skills, which are almost impossible to replace. NASA faces many challenges, both now and in the future. Chief among them is to safely maintain the International Space Station, support its research agenda, and ensure the safety of the crews while transitioning to the new Orion spacecraft and the Ares launch vehicles. To do this, NASA intends to increase reliance on our international partners and the new commercial orbital transition system capability, COTS. We need to better understand the implications of this strategy. And in fact, I note that Mr. Holloway in his testimony expresses some concerns about heavily relying on COTS until it's a proven technology. I hope to explore that today. In the post-shuttle era, COTS will hopefully provide a viable replacement of the shuttle's capability to deliver cargo and crew to the International Space Station. Establishing private commercial providers to perform these tasks would bring a new and much-desired dimension to spacefaring. NASA may also increase its reliance on international partners. The Russians will continue to play a significant role. But NASA also plans to use the European Automated Transfer Vehicle that will have roughly 3 times the cargo capability of Russian Progress. Development of the ATV has been delayed, but the first one is currently being shipped to its French-Guinea launch site, with launch scheduled for January of next year. If we become more reliant on the international community, I want to understand the effect of the international traffic in arms regulation restrictions on NASA's ability to work with our international partners, and again, Mr. Holloway's report addresses some concerns in that area. As NASA works to complete the International Space Station, it should fully examine the capabilities for exploration-related as well as non-exploration-related International Space Station research. The success of International Space Station as a national laboratory depends in part on maintaining sufficient research capabilities, which the chairman mentioned in his opening remarks, needed to prepare humans for long-duration lunar missions, among other things. I remain vigilant about the temptation to backslide into pre-Columbia behavior, burdening NASA to do too much with too little. Demands on NASA must be tempered. Furthermore, this administration and Congress must deliver the resources needed to complete what has been assigned. That means adequate budgets in fiscal year 08 and beyond. I'm concerned about this year's appropriations. The $18 million reduction from NASA's request for International Space Station reserves and the $85 million reduction in needed replacements for the tracking and data relay satellite system represent a fiddling at the margins that cumulatively invites more serious consequences down the road. When the world thinks of NASA, it envisions human space exploration. We are once again laying the foundation to explore beyond low Earth orbit. Human spaceflight is one of the most inspirational undertakings we do as a nation. Indeed, other nations now strive to emulate our successes because they recognize the great national prestige that accompanies human space exploration. By the way, I have been heartened in reading the testimony of the witnesses about where we are in the space program today. Looking back, I was a newly elected congressman a couple weeks into my tenure when we had the last disaster. And it is with a great deal of optimism that I read the remarks and the testimony about where we are today, given where we could be. Finally, NASA often makes the difficult look easy, but significant challenges await. I welcome today's distinguished panel, and thank you for taking the time to help us better understand and prepare for those challenges. In particular, I want to thank Mr. Bill Gerstenmaier, and thank you for your long-term dedicated services. With that, Mr. Chairman, again, I want to appreciate the work that you and the staff has done to prepare us for this hearing.
Thank you, Mr. Feeney. At this point, I would like to make it clear that there are members who wish to submit additional opening statements. Those statements will be added to the record without objection, so ordered. At this time, I'd like to introduce our panel of witnesses today, and I'll introduce all 4 witnesses, and then we'll move back to my left, and we'll start with Mr. Gerstenmaier. But Mr. Bill Gerstenmaier is here, as we've mentioned, both Mr. Feeney and myself, who's the Associate Administrator for the Space Operations Mission Directorate at NASA. And next to him, we have Mr. Tommy Holloway, who was the Chairman for the ISS and Independent Safety Task Force Report, which was completed in February of 2007. Next to Mr. Holloway, Dr. Paul Neitzel, who's a Professor of Fluid Mechanics at the Georgia Institute of Technology. And finally, we have Ms. Christina Chaplain, who's a Director of Acquisition and Sourcing Management at the Government Accountability Office. Welcome to all of you. I think all of you know that spoken testimony is limited to 5 minutes after each, and after which the members of the subcommittee will have 5 minutes each to ask questions. We'll start with Mr. Gerstenmaier.
Chairman Udall, Ranking Member Feeney, thank you for inviting me here today. It's my privilege and pleasure to represent the International Space Station and Space Shuttle teams. I've attempted to answer your questions in my written statement, and I'll use my opening remarks to expand slightly on my written statement and provide kind of the latest status of where we are with both shuttle and station. This is a very dynamic time in both programs. It's also been a very exciting time because the work we're doing now directly supports the future of human space exploration. Lessons we've been learning and will continue to learn as we live and work aboard the space station will help when we undertake our new exploration of the moon, make our first steps on Mars, and the United States leads the expansion of humanity's reach into the solar system beyond the current confines of low Earth orbit. The work we're doing today clearly helps and supports that activities in the future. Take, for example, yesterday the space station crew performed a 7-hour and 41-minute spacewalk to complete several critical tasks for the continued assembly of space station. Most likely you've heard about how the crew disposed of the early ammonia servicer device carrying 300 pounds of ammonia. It had to be removed to allow for the P6, the truss that sits up on top, to be moved to a new location on STS-120 scheduled for launch in October. But the thing that's important is they did many other tasks as well. They changed out a remote power control module, an electronic circuit breaker. This device provides power, or redundant power, to the mobile transporter. That's the crane that runs up and down the truss of the space station. That crane needs to be in a position to install the truss that's delivered on this next shuttle flight. So that circuit breaker had to be changed out to allow the shuttle flight to occur and be launched. They also cleaned some debris off of a seal. The teams went ahead and actually took the arm earlier and looked at a seal on the outside of space station. This is a pressure seal that allows the modules to, when they dock together, to be sealed and keep the vacuum away from the crew side. We noticed some debris that had accumulated on that seal. It was carried up in the shuttle on one of the seals and got stuck there. The crew went out and cleaned that debris off so then we can move another mating adapter there. And that activity is critical to an event that will occur later this month. Then the last thing that they did was, I think the thing that's important is to see how all these are connected to the future events and future flights. They're not just related to the next flight, but they're related to a flight that may be occurring in the fall or may be occurring in activity later this month. And that's the complexity of space station. All the tasks are interrelated, not a single dimension. There's multiple interactions between all the different pieces. While the space station team was doing the spacewalk, the shuttle team was busy getting the shuttle ready for launch down in Florida. The teams have done a good job getting that vehicle for launch on August 7th. Tomorrow we'll begin a 2-day readiness review to make sure that everything is ready for that flight, that everything appears on track. The weather's been a little tough in Florida in the afternoons. So there's been a lot of thunderstorms, and the teams have been able to work around those thunderstorms. And things look pretty good, and we'll have an extensive 2-day review, and we should be ready. Again, I think the teams have established a strong rhythm moving forward with assembly. We recovered from the hail damage that occurred to the tank earlier this year. That was an amazing team effort across the teams to get that tank repaired. That tank performed exactly as it was designed, did exactly what it was supposed to do. We repaired about 6,000 damage sites on that tank, and the team did a phenomenal job with that. So again, I think things are moving forward, and we're poised for the future. The work we're doing today postures us well for the activities in the future.
Thank you, Mr. Gerstenmaier. Mr. Holloway, the floor is yours. If you'd turn on your mic, Mr. Holloway.
Thank you.
That's better. Thank you.
Chairman Udall and Ranking Member Mr. Feeney, thank you for the opportunity to appear before you today. I will report on the observations and recommendations of the International Space Station Independent Task Force. I will call the task force. As required by the National Aeronautics and Space Administration's Authorization Act of 2005, the task force was formed to assess the vulnerabilities of the International Space Station that could lead to its destruction, compromise the health of the crew, or necessitate its premature abandonment. The task force offered its recommendations in the form of a final report which was submitted to NASA and the United States Congress in February of 2007. These recommendations, if followed, should strengthen the ISS program by increasing the likelihood of mission success and mitigating risk to crew safety or health. I also should stress that for these recommendations to be effective for the IS to remain a robust and healthy program, sufficient support from the administration and the Congress is required to ensure that the resources are provided and the safety-critical aspects of the ISS assembly and operations are enabled and maintained. The ISS is an extremely large and complex vehicle, and at the time of the task force report had a current living volume of 15,000 cubic feet and a weight of 455,000 pounds. Planned assembly will expand that to 33,125 cubic feet and 855,000 pounds. Hardware and software are developed and tested all over the world, launched in Florida and at Baikonur, and assembled on orbit and at an altitude of approximately 215 nautical miles. Major systems including electrical power, cooling, data handling, and navigational control are distributed throughout the station and are expanded and integrated as assembly progresses. Station assembly to date has gone exceptionally well and is a tribute to the ISS and shuttle teams. Anomalies occur but are dealt with quickly and with outstanding results, as demonstrated in December 2006 by the solar wing retraction problem, where the spacewalking astronauts assisted in the retraction of the jammed solar wing. These factors plus result in a complex and a distributed program with a highly technical and distributed management system that must be staffed by highly skilled engineers and skilled and experienced managers. Maintaining critical technical and management skills in the ISS program as the ISS matures and NASA's exploration program staffs up will be a challenge requiring proactive and continuing attention by NASA management. The ISS on-orbit vehicle is a robust and, to the extent practicable, meets a two-failure tolerance requirement to minimize the likelihood of a catastrophic event. The Russians and U.S. systems provide robust redundancy from dissimilar hardware and designs in critical systems such as guidance, navigation and control, environmental control and life support, and crew cargo transportation. For most safety-related issues, time is available to mitigate vulnerabilities by switching to redundant systems, performing maintenance repairs by the crew, or relying on consumable reserves until a future logistics flights can be launched to the station. Time-critical exceptions to these failure tolerances are uncontrolled fire, collision with micrometeoroid or orbital debris, toxic spills, or collision with a visiting vehicle. However, the task force found that the system's design, testing, and adherence to operational procedures provide adequate controls, or that adequate mitigations are being developed by NASA for these conditions. I will now summarize the principal observations and recommendations of the task force. First of all, the observations. The International Space Station is currently a robust and sound program with respect to safety and crew health. Safety and crew health issues are well documented and acceptable and are either adequately controlled or mitigations are being developed to maintain acceptable risks. The ISS program has strong and proactive cross-cutting functions that, if continued, should provide adequate indications and warnings that will avoid events that might lead to destructions of the station. International Space Station currently has an experienced and knowledgeable and proactive team, both internally and in institutional technical checks and balances. Provides the defense for process and management failures that might lead to safety or health issues. This posture must be maintained to continue the station's successful operations. Micrometeoroid and orbital debris penetrating the living quarters or damaging critical equipment is high safety risk to the crew in the station. There are significant programmatic risks associated with completing the ISS Shuttle manifest and providing robust post-shuttle logistics capability that threaten the ability to support a viable station. Design, development, and certification of the new COT system capability for ISS resupply are just beginning. If similar to other new programs, it most likely will take much longer and cost much more. Current international traffic and arms regulation restrictions on NASA are a threat to the safe and successful integration and operation of the international. Principal recommendations of the task force are the International Space Station program should place the highest priority on option to decrease the risk of micrometeoroid and orbital debris. NASA should develop and implement plans to maintain station-critical skills and experienced managers. The administration, Congress, and NASA should support the completion of the current shuttle manifest of the International Space Station, including ULF-4 and ULF-5, to assemble a viable station and provide spares for the long-term operations. The administration, Congress, and NASA should support a proactive and phased post-shuttle logistics transportation program, including adequate funding to ensure that adequate logistics and spares are available to maintain a viable station. The Department of State should grant immediate relief from the international traffic and arms regulation restrictions in the form of an exception to allow NASA contractors to direct interaction with their International Space Station's international partners and their contractor. Other details of the principal recommendations as well as additional recommendations can be found in the body of the report, final report of the ISFTF task force. And finally, it should be noted that NASA's support and responsiveness to the task force was excellent through the process of developing the data and material required to accomplish the charter of the task force. Program manager and his team supported the technical review meetings and provide invaluable insight and technical data on the issues associated with the task force charter. Thank you very much.
Thank you, Mr. Holloway. Dr. Neitzel, the floor is yours.
Mr. Chairman, Ranking Member Feeney, and members of the subcommittee, thank you for inviting me to testify before you today on these important matters relating to the Space Shuttle and the International Space Station. My name is Paul Neitzel. I am a professor of fluid mechanics and mechanical engineering at Georgia Tech. I am here today as a representative of NASA's external research community and shall do my best to communicate to you some of its concerns. The International Space Station, or ISS, has always been justified in large part as providing an experimental platform operating in a unique environment of weightlessness, or microgravity, to permit research relevant to future human space exploration, as well as fundamental and applied research that can increase our understanding of certain phenomena, potentially leading to enhanced terrestrial applications. NASA, through the 1990s, had developed an impressive external research community in the life and physical sciences to investigate such questions. This growth was a conscious decision on the part of the agency, made both to access new ideas and to expand the ground-based research program to ensure that the very best projects requiring access to microgravity could be identified and subsequently flown. This community included the best researchers in the United States in their respective fields. In the 2003 Office of Biological and Physical Research Task Book, more than 1,700 co-investigators and nearly 3,000 students were identified as working on roughly 1,000 tasks. In the aftermath of the tragic loss of the Columbia and her crew in February 2003, and the mission shift resulting from President Bush's 2004 vision for space exploration, NASA made a decision to terminate all external, non-exploration research and to significantly cut back on the number of external exploration projects, effectively wiping out the community of researchers that had been assembled. Some of NASA's rationale for doing this is understandable, given the loss of a vehicle with which to continue the assembly of the ISS and the minimal budget plus-up of $1 billion over 5 years devoted to the implementation of the vision. NASA is an agency that is always being asked to accomplish too much with too little. However, it is my belief that NASA's decision to proceed in this fashion is short-sighted and inconsistent with developing the types of systems that will best allow us to return to the moon between 2015 and 2020 and prepare for more ambitious missions. The vast majority of fundamental and applied scientific research in this country is conducted at colleges and universities, where faculty work in conjunction with students from undergraduates to postdoctoral research fellows to make the breakthroughs that help drive our economy. By shutting out input from this community, NASA not only denies itself access to potentially groundbreaking results of relevance to its mission, it also effectively guarantees that future workers it will require will be neither motivated to work on NASA-related problems nor even be knowledgeable of them. In addition, the hundreds of researchers who have had their NASA research programs terminated are moving on to other pursuits and are likely to be unable, if even willing, to return to problems NASA will need to have solved in the future. The restriction to a small number of exploration-related projects is also likely to cause NASA to lock into choices at an earlier time than it should for systems currently under development. Consistent with the President's vision, NASA should be exploring the development of systems that will permit future missions that may be of much longer duration than a trip from here to the moon. Such missions will require the development of new, mass-efficient, dual-use systems that will accomplish their functions both on a reduced gravity heavenly body as well as during the extensive period of zero gravity required to get here. ISS is the only research platform capable of investigating the latter regime. Finally, the elimination of fundamental ground-based and microgravity research denies the agency and the country the possibility of results from curiosity-driven research that has been the hallmark of academic research throughout history. Such work may or may not have immediate application. Fundamental work done by Lord Rayleigh on the breakup of liquid jets roughly 100 years ago forms the basis of technology used in both the inkjet printing and rapid prototyping devices of today. NASA's plans for the utilization of the ISS by researchers funded by other federal agencies are, in my opinion, unrealistic at this point in time, given the long lead times required to develop flight hardware and the finite lifetime of the ISS. The ISS National Laboratory concept, while one I support, is but a hollow shell without dedicated funding to enable both the research to be done on ISS and the expensive cost of transporting experiments to and from it. This funding, furthermore, must be fenced off from the standard NASA budget to prevent it from being redirected by the agency to other needs. Without a vigorous program of ground and space-based research designed to exploit the unique environment of the ISS, we are squandering this valuable resource, we are potentially relinquishing our leadership in space-based research to other nations, and we are dimming the spark of discovery that motivated many of the current generation of such researchers, including yours truly. Thank you again, Mr. Chairman, for the opportunity to appear here today. I am happy to try to answer any questions the subcommittee may have.
Thank you, Doctor. Ms. Chaplain, you now have 5 minutes to present your point of view.
Thank you, Mr. Chairman and Ranking Minority Member Feeney. Thank you for inviting me to discuss challenges faced by NASA in completing and sustaining the International Space Station and retiring the Space Shuttle. As you know, these endeavors are part of the broader vision for space exploration, which require careful management of investments, facilities, workforce, international partners, and suppliers. Clearly, any delays or problems in completing and sustaining the space station itself may well have reverberating effects on NASA's ability to ramp up exploration efforts or to support other important missions. Today, I would like to present preliminary results of our work related to the station and the shuttle. While they're preliminary, many have been echoed in other studies and identified by NASA itself. First, there are significant challenges related to NASA's ability to execute its plans to use the shuttle to complete the station. The January 2007 Shuttle Manifest projects that NASA will launch 16 flights before retirement of the shuttle fleet in September 2010. One of these has already been launched. Of the 15 remaining missions, one is reserved for the Hubble telescope, and 2 are designated as contingency missions that are slated to bring materials critical to station sustainment. On average, when counting the contingency flights, NASA will need to launch one shuttle every 2.7 months, an aggressive schedule when compared to recent launch timeframes. Due to vehicle traffic constraints, the minimum time required between shuttle launches to the station is 35 calendar days, so while the manifest is aggressive, it is achievable. There is, however, little room for unexpected delays caused by weather damage or launch debris, which have proven to impact the shuttle launch schedule significantly. In addition, there are potential trade-offs NASA can make in order to position what is needed to sustain the station after the shuttle's retirement, and some of these trade-offs have already been made. However, the potential deletion of such items as Node 3 and the cupola would have a substantial impact on the quality of life on the station, the ability to conduct research, and, in the case of the cupola, the ability to use a robotic arm to assist in docking newer transportation vehicles. Second, we have previously reported that there are significant challenges in ensuring NASA can retain critical skills to manage the shuttle program through its completion. NASA has made progress in implementing previous GAO recommendations on this issue. For example, it has developed an agency-wide strategic human capital plan, developed workforce analysis tools, and is mapping available skills of the shuttle workforce with the skills it will need in the future. It is important that these actions be sustained throughout the transition and that NASA also measure its progress, identify gaps or obstacles that need to be addressed, and sustain a high degree of coordination with its centers. Third, there are considerable challenges with filling the gap between the shuttle and the new NASA-developed vehicles to service the station. For example, NASA expects that the commercial sector can develop transport vehicles that can take equipment and ultimately crew to and from the station during the gap. However, our work has generally found that space development efforts often encounter schedule delays and technical problems, particularly when they are seeking to obtain significant advances in technologies, move forward amid unknowns, or are managed without adequate oversight and insight. Risks may be high in these partnerships given that the suppliers do not have long-standing relationships with NASA and the development of the vehicles represent totally new endeavors for them. Therefore, it is critical that NASA establish clear and consistent guidance, limit requirements changes, and ensure it has visibility into the progress being made by the commercial suppliers. NASA's options, in addition to the commercial vehicles, which include both the European and Japanese vehicles, which are new, and the legacy Russian vehicles. However, NASA's reliance on these vehicles to augment resupply activities after 2010 assumes no further delay in development. Moreover, there are limits to what the payloads these vehicles can carry. The Independent Safety Task Force also reported challenges involved with working through laws and regulations governing the transfer of technical knowledge, though the Station Program Office reported to us that immediate hurdles have been overcome with respect to the European vehicle. In addition, continued use of the Russian vehicles will require the U.S. to renegotiate exemptions to the Iran, North Korea, and Syria Non-Proliferation Act. Our review will further examine risk mitigation efforts related to the gap between the shuttle and NASA-developed vehicles, as well as the shuttle manifest and workforce issues. We look forward to continuing to share the results of that work with this subcommittee. Thank you. This concludes my statement, and I'm happy to answer any questions you have.
Thank you, Ms. Chaplain. Thanks again to the entire panel. This was very, very helpful, and we'll now begin the first round of questions, and the chair will recognize himself for 5 minutes. And I want to focus in on the issue of logistical support station. And Mr. Holloway, from your testimony, you feel like this is the most serious issue facing the program, that is this logistical support for the station after the shuttle is retired. You say, for example, that inadequate logistics will result in a serious decrease in the utility of the station and could result in its abandonment. And then you go on to recommend that the administration, Congress, and NASA should support a proactive and phased post-shuttle logistical transportation program, including adequate funding of approximately $1 billion per year above current allocations to ensure that adequate logistics and spares are available to maintain a viable station. You recommend as well that NASA not commit the ISS to an unproven logistics support system such as COTS. However, at present, NASA appears to be counting on COTS as its main post-shuttle logistics system, and the administration's given little indication that it's considering this $1 billion increase per year suggestions. How much risk is being added to the ISS program by these actions in your? And Mr. Gerstenmaier, I'm going to give you a chance to respond as well.
Mr. Chairman, first of all, that's a very difficult question to answer. But at the time of the conclusion of the report, there was a 120,000-pound shortfall in logistics capability that was dependent upon some future transportation system, either the COX or the merge and partner capability or the Russian Progress vehicle. That's a tremendous amount of logistics, and as you well know, you need food, water, oxygen, and maintenance spares to be able to operate the station. Without that, you eventually will have to abandon the station. The COTS program, I'm sure that we're all are very anxious for it to be successful, and are looking forward to the day when commercial activities can routinely launch cargo and people into low Earth orbit. That will be a great day for the space program. But the building of a rocket, of course, is a difficult endeavor, but with the proper reliability and safety aspects, but also building a vehicle that can approach and be attached to the space station is a daunting technical challenge driven by the appropriate, I must say, safety requirements that are levied on that vehicle. The European Space Agency has been working on that for the ATV for approximately 10 years and have worked very diligently, and I must add at least for the last 6 or 8 years have had a very good technical team. And they are just now emerging with the opportunity to launch the first of next year. So in the long haul, I would think it would be unlikely that the COX will be able to provide a substantial part of the logistics program in the most critical period following the retirement of the shuttle program. I hope I'm wrong, but I expect that it will be several years after that before routine commercial activities are viable. So I think depending totally upon COX would be a significant risk to the long-term viability of the station.
Mr. Gerstenmaier, would you care to respond? And you have 45 seconds to respond. And actually, we'll come back to you for your time.
Okay.
Yeah. The ranking members offered to provide you additional time, so respond at the length that you need to respond, please.
Well, first of all, we agree that one of the long-term challenges of the space station is logistical support. This is clearly something we need to go work on. Since the task force reviewed the program, we added in some minimal progress support to provide some logistics capability to space station. And what we did there is we added just the absolute minimum, essentially, to keep space station viable. We didn't add any additional spares or any additional cargo in that contract addition. And we left room for the commercial orbital transportation systems to come online. We also have got agreements now for the automated transfer vehicle, the European vehicle, and also the Japanese vehicle to provide cargo to station. So we have an understanding of the basic transportation plan that we need in the future. We have an approach that kind of goes day by day, in a sense, and allows us to monitor these activities such that we can anticipate a problem that's coming and still have a chance to react to it before it becomes a major problem to us. So the first step is we're using the shuttle and the two logistics flights to essentially outfit space station with all the spares that we can before the shuttle departs. So we anticipate with our basic failure rates we see on our components, we'll have 2 to 3 years of margin after the shuttle retires. That station will be viable with the spares that we've pre-positioned. So in other words, we put items that we anticipate may fail on board station ahead of time, so they're there and they're pre-positioned. So that buys us some time. We'll also know next year how well the COTS program is progressing. We'll get a chance to see they have a demonstration flight towards the end of the year and 2 other flights at the first part of the year. That will give us critical information and will tell us whether COTS is viable or it looks like it's going to be delayed a little bit. That'll be very important data for us. We'll also get to see the automated transport vehicle fly in January. That'll provide critical data to us. So I think we have a logical and stepwise plan that we can protect for this logistic period, or this logistic support period when the shuttle retires. We have time to detect a problem that's coming to us before we're in a situation where we cannot react, and then we have some controls to react depending on what we see. The other big unknown is we don't know what the failure rate is going to be on these components. We've only recently activated the truss components. That's the hardware that sits out on the truss. Some components are on the inside of the space station perform significantly better than our analysis had shown. So we may be better from a logistics resupply plan or failure rate standpoint. Again, we'll know next year. So I think next year we'll be in a much better posture to see what the future looks like, to see where we are, and we still have time to react with a plan. We're working this, and we're aggressively looking forward to solve this problem.
Gerstenmaier, thank you, and I look forward to returning to this topic in the next round. And at this time, my pleasure to recognize the ranking member, Mr. Feeney, for 5 minutes.
Well, thank you, Mr. Chairman. Yeah, I want to get back to COTS at some point, too. But first, I want to address another issue that the task force brought up, Mr. Holloway, and that is referred to as the Micrometeoroid and orbital debris problem. And I want to make sure I understand your presentation right. On page 2, you say that over a 10-year period, the ISS has a 55% chance being struck by either debris or micrometeoroid. Is that right? With a 9% risk of a catastrophic result.
That's correct.
That with implementation of changes that are available that you've recommended, that risk can be roughly cut in half.
That's also correct.
We know that, and this is a reminder that despite the great successes we've had, by the way, the most recent one was the brilliant work that the people at NASA, the United Space Alliance, and many others did, many other contractors did, working in a seamless team to get us through the hailstorm issue from February and get us back in a very timely manner. So it's remarkable, but this is a reminder as you testify that space exploration is inherently risky. Does anybody on the panel have an opinion about let me ask the question first this way. Mr. Gerstenmaier, has the space station had to be maneuvered at all to avoid any of the debris from the Chinese ASAT test where they basically blew up their own?
No, we did not maneuver the station for that. The problem with some of that debris is it's so small it can't be tracked very effectively.
Right.
So then you don't know how to maneuver. The good thing about space station was it was at a low enough altitude that the debris cloud from that satellite destruction transited the station orbit very quickly. So it was a fairly short-term threat to space station. Space station has debris panels on the outside to protect us from this small debris that was called out in the report. Since the report, we've added debris panels on the Russian service module. Those were done in an EVA this summer or early this spring by the Russians, so that activity is complete. We've also got some debris wings which will shield the service module. We've had discussions with the Russians, and we're currently planning on, we put those on a shuttle flight in the future to go ahead and carry those up to space station. So we've implemented one near-term protection. We have plans for another one that's moving forward, and we're still looking at the recommendation of putting additional protection on the Soyuz and Progress vehicles, and we're still working with our Russian partners on that protection.
Well, in Mr. Udall's, Chairman Udall's home state, they do a remarkable job at the Space Wing tracking some 8,000 or 10,000 pieces of so-called space junk or space debris. But if this is as big a concern as the task force recommends, Mr. Holloway, one of the things we need to do is to convince international spacefaring nations, starting with the Chinese, that turning one obsolete satellite into 800 or 8,000 pieces of space junk is a risk as nations want to put human beings into space. So this should be And there are lots of other reasons why the Chinese should not have done what they did, but at a minimum, the fact that if the Chinese and other spacefaring nations want to have peaceful human exploration of space, they have to respect the fact that they just can't put missiles out there. So if anybody cares to comment on that, that's fine. Otherwise, it would just be taken as a speech. Mr. Gerstenmaier, going back to COTS for a second, NASA right now acknowledges a $300 million shortfall in the ISS crew cargo services budget based on current estimates, as I understand it, with an additional $600 million shortfall held as a lien against the Exploration Systems Mission Directorate budget. We're all anxious and hopeful that COTS is going to be successful. You talk about a number of tests in the next 12 months or so. When will we have to address the issue that the task force has raised about a potential $1 billion shortfall in servicing the station post-shuttle if COTS and our other international partners can't achieve what they... When will this decision be timely?
Again, kind of as I described in my earlier remarks, it's really a process. We'll gain some information on what our failure rates are of the components throughout this next year. We'll also get a chance to see the providers' viability and see how well the spacecraft perform, which will be important to us. We'll also get an idea of what the cost of that cargo and carrying capability is. Through this next budget process we're working on now for the next budget cycle, we're refining some of those estimates, taking into account this data. So probably for next year's budget activity, we'll be prepared to discuss with a little more certainty about where we are in terms of budget threats and things. But again, there's many variables here, and we're actively analyzing those and gaining data to see if we can understand what are the options.
Thank you, Mr. Feeney. Mr. Udall had to step out of the room and ask me to take for a few minutes, and seeing as how I was the next one up for questioning, I will yield myself the next 5 minutes. Mr. Gerstenmaier, let me start with you. I have had a number of meetings in the last several months with people who have been working on the alpha magnetic spectrometry, the AMS, and I know that this is something that has been taken off of the manifest from what I understand, and I'm at some point in time wanting to seek ways that we will be able to hopefully get it put back on. But what was NASA's original agreement regarding the AMS? Was it and what's the what was the original agreement? To start with that, I have a whole series of questions on this, if you don't mind.
The original agreement was to fly a precursor mission, which we did on STS-91, and that was to look at the basic technology and the basic. We also agreed to provide some integration activity to essentially help build up the cargo and interface it for a launch vehicle. We're still continuing to do that, and we're still continuing to. And originally we had agreed to try to fly to space station in a long-duration manner. But after the Columbia tragedy occurred, we immediately informed the DOE that we could no longer live up to that second commitment. And the reason there is just the discussion we've had here is that we had this critical logistics sparing needs for space station, and we have a limited number of shuttle flights. So we really have no option other than we cannot fly the device without taking some critical spares off that could jeopardize the overall health of the space station. So as soon as we knew that, the administrator informed the DOE partners we could not meet that second.
What's the response of the international partners to NASA for canceling the plans?
Our interface is primarily with the Department of Energy, and we've not heard anything, I don't think, directly from the.
Might NASA be required to pay any penalties?
Again, I think it was the way the agreement was written was it was written as a best effort, and we lived up to the intent of what.
Think that it might jeopardize future collaborations between or among potential partner nations on other projects?
Again, I think our partners recognize the complexity of what we're trying to do when we had the Columbia tragedy. You know, we're still launching their primary laboratory modules. We're still meeting our international commitments to them to provide research facilities. still providing substantial support to all our international partners in that respect. And I think they recognize the difficult situation that we were placed in, and they recognize the rationale for the decision that we had no choice to make.
Just for the record, I have met with some of the representatives of those international partners, I think 5 of them. And from what I understand, this project was one that was to cost around $1.2 billion, and the international partners were going to pay 95% of the cost of the project. They have essentially completed the work that they were doing on it, and the largest part of what we were going to do, I think, was to put it on the International Space Station. Those folks with whom I have spoken are not the happiest campers in the world right now. So there is some potential downside for this not happening. A recent Department of Energy sponsored external review of AMS supports the scientific validity of the AMS experiment. NASA's response is that, quote, the review does not evaluate AMS in the context of NASA's broader program of astrophysics research. NASA's Science Mission Directorate relies on broad reviews of science disciplines conducted by the National Research Council of the National Academies of Science to establish priorities among potential missions. Because the DOE review took place outside of this framework, it is of limited usefulness to NASA. Mr. Gerstenmaier, was the review conducted with the awareness of its limited usefulness to NASA, and if so, what was its purpose?
I'm really not in the right position to answer that. I think that would be a better question directed at the Science Mission Director.
Okay.
I'm more on the facility side and not on the scientific research.
Fair enough. Thank you. Would any of the other witnesses care to comment on any of the, Dr. Neitzel, please?
I'd be happy to comment because I think that this occurrence speaks directly to what NASA says it wants to do with respect to the implementation of a National Research Laboratory aboard the ISS. NASA claims it wants to go out and find other federal agencies willing to perform research aboard the ISS and to utilize this unique facility. And here's a perfect example of the Department of Energy stepping up to the plate and doing exactly that with the participation of all these international partners. And now NASA says it's going to remove this experiment from the Shuttle manifest. So that doesn't provide a lot of confidence that this model of having other federal agencies do research aboard the ISS is perhaps a viable one.
Thank you very much.
And my only comment to that is in the National Lab proposal, we recognize transportation up front as one of the key critical resources that need to be addressed up front. So in the case of AMS, we were forced into this because we lost our transportation system when Columbia disaster occurred. In the case of the National Lab, we recognize this as a weakness that needs to be addressed, and we're going to work it up front with our partners and not mislead them and assume that transportation is available. That is something that we have to work, and we're trying to provide a better expectations for what can be done with the space station.
It's something, obviously, that I have a significant amount of interest in, and I hope over time we'll look for some innovative ways that we might be able to find the opportunity to make this piece of equipment be able to be deployed on the International Space Station. My time has expired, and I would recognize the gentleman from California, Mr. Rohrabacher.
Thank you very much. Dr. Neitzel, is there anything that you can point to we have achieved science of great value for Shuttle? Excuse me, on station.
On board the station, the number of investigations that have been done so far have been somewhat limited due to the compression of the assembly sequence post-Columbia. I can't say I'm personally aware of any experiments that I would say have led to groundbreaking research, but there are some experiments that have gotten some results that could be of utility.
But nothing near the value that we were led to believe would result from the space station.
Perhaps not yet, but that's partly due to the fact that the resources are limited and the transportation resources to carry these payloads are limited. So we have many pieces of facility-class hardware that are yet to be flown to the station and utilized.
We're talking now about central station. Is there something that we might be able to do in terms of has NASA offered this asset properly to the private sector and to a university system, or something else that permit us to open up opportunity?
I can't speak too much to the private sector. That would be something Mr. Gerstenmaier would be better qualified to address. However, from the standpoint of the academic community, NASA's been sending the wrong message with the decimation of that research community effectively December of 2005. There were several hundred investigators who were essentially removed from...
Given budget restraints, and people can all, believe me, if you just say to we're going to subsidize what you want to accomplish, given budget restraints, is there something that we can, some way we can attract more investment from the universities or from the private sector in a way that would be necessary bottom line for us actually to get it done?
Well, there needs to be a baseline research community in place to effectively utilize the International Space Station upon assembly complete, and that community no longer exists. Now, last year, several of us were asked to provide some estimates for the amount of funds it might cost to keep alive a research community in this era, where we have limited opportunities for flight, but could still have extensive ground-based work that could be developing flight experiments, therefore enabling their conduct aboard the ISS at assembly complete. That community came up with a figure of on the order of $70 million, which the budget is enormous, but in the scheme of things, it's not a particularly large number. And it seems to me that kind of figure ought to be able to be found easily within the existing NASA budget or through an additional appropriation.
I'll have to say that I don't think $70 million is easily found in anybody's budget these days. By Griffin credit, he's trying his very... Every time you turn around and people suggest that finding things like $70 million is easy, that just isn't the case anymore. And I think we need some very creative approaches, and I'm very... I'm happy that NASA is trying to bring the private sector in to bring down some of the costs. Of course, there is a risk factor in that perhaps the private sector launch capability that we would hope was being developed that might not work. Do we have? Are not the Russians a backup? If Elon Musk is not successful and our own private sector is not achieving the goals that they've set for themselves?
I think our international partners, the Russians, also the automated transfer vehicle, and then the Japanese HTV transfer are all viable backups for us. We still have the Iran-Syria Non-Proliferation Act that we need to deal with beyond 2012, and we'll at the right time.
And in terms of actually utilizing the station, and what we're talking about is utilizing it more for the private sector to go in and let them try to find some creative uses for us. That leads me to Gerstenmaier, idea of expanding enhanced use leasing. And in 2003, NASA was granted enhanced use leasing authority to permit the agency to lease underutilized property, other consideration, as a demonstration program at the Kennedy Space Center and at Ames Research Center. Now, we've expanded that, or we've permitted that to sort of as an example to see what can be done. have we learned something? Can that now, are there other facilities, other NASA facilities can be brought to play that are now underutilized?
We would like to open that up to all NASA centers. We think especially as the shuttle systems are retired, we'll have some facilities available to us that would be attractive potentially to the commercial sector to utilize and to lease from us. And then we'd like to take the funds from that excess capacity and use those for other things for NASA direct adventures and activities. So we think that the model worked well with the 2 centers. We would like to expand that to all 10
Is
centers.
there any guesstimate as to how much money might be, revenue might be generated from?
I don't have an estimate with me today, but we could take that for the record and see.
Would it be possible that with this approach that we might be able to come up with $70 million that might be used someplace else, for example?
I think based on the limited results we've seen from the 2 centers, I think that's a little bit on the high side of what's available, but it sure helps. And as you described in today's tough budget environment, any funds that we can get and use is definitely advantageous to us. And we think there'll be some facilities that can definitely be a win-win for the government and also for the private sector to get use of a unique facility and a unique location.
This isn't the old days where people can just find $70 million, so we have to make sure we use every creative idea we have, and we have an asset in the space station, and we try to see if there's some creative uses, what could possibly go on there where we could generate some more, not just savings in terms of how we utilize the station, actually the generating of. Thank you very much.
Gentleman makes some very strong points in comparison to the cost that we've paid. I think paid so far some $30 billion in its construction. $70 million does not seem like a huge amount in comparison, and I think we'll spend $100 billion over the lifetime of its operation. So let's hope we get it. Switch to something that I don't want this committee to be taking sides on, but I would like to know, Mr. Gerstenmaier, the status of contract negotiations between the striking International Association of Machinist Workers who are involved in the processing of the Space Shuttle and the United Space Alliance. Can you give me an indication of what's happening?
I don't have direct insight into that. Our contractors are involved in those discussions and negotiations. At this time, the strike is still ongoing, and we're able to essentially continue to process with limited support from our non-union workers down in Florida, and things are. I don't have a status of the latest negotiation.
Has NASA evaluated the safety concerns voiced by the Striking International Association of Machinists?
Yes, we have. We've been very careful to make sure that we're not progressing in any unsafe manner, that we have the proper skills training for all our workforce, that we haven't cut back on any of our certifications of any of our workers for any jobs or any tasks in light of this. So we've made sure that we are processing the vehicles in a safe manner, and so far we've done that. If we see anything that's out of bounds, we would stop the activity and not proceed.
Can you give us some of the steps that NASA's taken to ensure that the shuttle processing activities associated with the next shuttle launch are being conducted safely during the strike?
Yes, we provided some additional insight and oversight during some critical activities that to make sure that we had all the right personnel supporting the activities, especially some of the vertical assembly building processing. We brought some extra NASA safety inspectors in, some extra quality folks in to actually watch that activity to make sure that it was occurring correctly. We also reviewed the certification and training records to make sure that the employees doing the work were adequately trained and prepared for the jobs to which they were assigned.
And then what are the implications, if any, of the strike for the shuttle launch schedule?
Again, near term, we don't see an impact to the near-term launch schedule. If the strike continues, we'll have to continue to evaluate and to review. And again, as I stated, if we see anything that doesn't look right, we'll stop the operation and no longer proceed. But we're continuing to evaluate, and so far we've been affected, but not overly affected.
Thank you. Your testimony notes that, quote, when we fly systems as capable and as complex as the Space Shuttle and the ISS in such a dynamic environment,
we always have to be prepared for the unexpected and agile enough to react quickly and effectively, unquote. What contingency plans does NASA have in the event that weather or some other unforeseen event delays the shuttle launch schedule to the point that assembly of the ISS cannot be completed by 2010, the date that the shuttle is supposed to be retired and no more flown?
We've put together a manifest that has some robustness in it. You can see that our last shuttle flight ends in July of 2010, and we have until September 30th of 2010. Some margin there. We also have the ability to optimize that manifest a little bit and move some things around to actually gain some more margin if we need to, if we have another weather event and we can around. We also have the sequence and the flights ordered in the sequence that if we have to drop a flight at the end, it's our lowest priority flight, and we would make that evaluation when the time comes to drop the appropriate flight that needs to be dropped if it falls beyond that time frame. And again, so I think we've prepared as much as we can. We have robust manifests. We look at this from an overall standpoint. It's not a single system that can cause us to delay. It's the entire system. We're looking at it continuously. We're prepared. We have some margin to take some other weather delays. And in fact, this year we plan 3 flights. We plan a flight in August, a flight in October, and a flight in December. Quite possibly that December flight may not occur just because of vertical assembly, building scheduling, and single high bay that's available. That flight may move into January. We've already evaluated that. That can occur without any impact to the downstream flights, and we'll still be able.
If somehow or other Congress did miraculously find the extra money for another flight, is it possible that we have the capability of building the fuel tanks and whatever else support to it, or is that gone?
We're in the process right now of terminating a lot of contracts and subcontracts. So at this point, we probably still could reasonably add another. We have enough ability to buy enough spares to potentially put together another flight. Later this year and into next year, we'll eventually lose that ability because we will have to turn off spares and suppliers. So we're kind of in a transition period. There's not a single point in time, but it's becoming more and more difficult to actually add an additional flight.
Mr. Holloway and Ms. Chaplain both, would y'all care to comment on any of those, please?
I would just add that if another flight was added, it would further compress schedule. So you're just adding a little bit more risk to that schedule that needs to be negotiated. The other thing I understand with some of these spares is that NASA is still learning their failure rate time periods, and that learning will occur for several years forward, and it won't be known till late in the schedule, do shifts need to be made, what should be on that last flight, all those. There's a lot of questions that are going to be out there for the next couple of years, just of the need to learn the lifespan of some of these materials that need to be on board.
What's magic about that schedule? Why couldn't a flight be added at the end of what is presently the existing schedule?
As I mentioned in my testimony, there's about they need 35 days between flights, and we've estimated 2.7 months between flights right now. So it's just adding another flight further compresses that time period to turn the launches around and get ready for the next one. It's still probably achievable, just adds more schedule risk.
But no possibility of extending that schedule?
Past 2010?
Mm-hmm.
You would have to ask NASA.
Okay, well, I tried to get your feeling of that. Mr. Holloway.
I believe the Space Shuttle team has a great deal of flexibility to deal with near-term and short-duration schedule upsets, such as Mr. Gerstenmaier mentioned. I think over the course of the next 3 years, I think they'll be able to deal with those short-term weather delays of a week or two, and so on and so forth. And in the near term, they can go much faster than they go for the long haul, if you understand what I mean by that, and can make up for lost ground. However, I would suspect that it would be most difficult to recover from a long-term delay, such as the damage to the tank that occurred.
Thank you very much. I recognize Mr. Feeney for 5 minutes.
Thank you, Mr. Chairman. One more question on the micrometeoric debris. Mr. Holloway, in your calculations where you say we can get it down over a 10-year period to a 5% risk of a catastrophic event, have you taken into account the fact that we expect to double the size of the space station before completion?
Yes, sir, though that was taken into consideration in the basic calculations that we provided to us by NASA.
Well, I don't want to be too alarmist. I live in Florida, and over the next 10 years, the chance that my house gets hit by a catastrophic event, a hurricane or tornado, it's probably at least a good 5%. So, but that's something that we all ought to be aware of. For Mr. Gerstenmaier, the task force has strongly recommended that the State Department should give relief from ITAR. They've done that in the short range here. But given the fact that we have, reports in the last 24 hours, for example, have talked about the Chinese domestic spying for both economic and military reasons, and they seem to have enhanced capabilities and access, which is very troubling. What type of plans does NASA have as it seeks these necessary waivers so we can get cooperation with contractors that do international work and international partners? What type of plans do we have to ensure that there is oversight that we do not allow critical technologies to get into the wrong hands?
In the case of space station, our partners are part of essentially a memorandum of agreement and government agreements that are in place that ensure that we don't transfer data back and forth amongst ourselves unnecessarily. So I think there's some protection already within the space station system itself. In the case of the automated transfer vehicle, we pursued through State Department and with our contractors all the necessary agreements, the technical associated agreements, to get in place to ensure that we would not transfer data inappropriately, and that's worked well. We still would like to have some more restrictions removed. The things that become problematic, for example, is if a failure occurs on the automated transfer vehicles that's approaching the space station, we need to have the ability to talk with our international partners about what that failure was and how it occurred to avoid that spacecraft from hitting the space station or causing it damage. And so we need some relaxation in those kind of dealings in the real-time environment. So we're seeking specific changes in specific limited areas that won't overall impact the transfer of critical information.
Mr. Gerstenmaier, in general, which of the task force key recommendations do you agree with, which do you disagree with, and which are you sort of undecided about?
I think we agree with all the recommendations, and we're aggressively moving out on them. They're going to take a significant amount of time for us to implement, in some cases multiple years. Some of them are out of our direct control. Some of them rely on State Department. Some of them rely on some potential congressional funding. But the ones that we have control of, we're moving out as fast as we can, and we anticipate we'll be able to satisfy all the recommendations. In fact, they were a very good set of data for us to work on.
There have been discussions about completion of a number of missions. Mr. Rohrabacher talked about one, Congressman Lamson when he was in the chair. Other than budgetary constraints and Congress's willingness to fund it, is there any technical reason that you're aware of? And Mr. Holloway, same thing, that if the shuttle had to fly an extra 2 or 3 missions, it took an extra 6 months or a year. Is there any technical reasons we're aware of that's a practical impossibility for technical reasons or capabilities?
There's not a technical reason that can occur. The problem becomes budgetary, that if that money then comes from exploration, then that takes money away from the constellation vehicles, the Orion and Ares vehicles, and delays that generation of the next vehicle because the NASA budget is essentially capped at a certain level. So that's the constraint. Technically, it's viable, but then programmatically, it just makes a longer delay in where we are. The other piece is that the shuttle is really necessary for these assembly flights, and that extra complexity and that extra care is warranted. We would like to migrate to a newer vehicle that's more dedicated to crew transport, that's a little simpler to operate, potentially a little bit easier to operate than the shuttle. So we want to get to the new vehicle as soon as we can. So delaying the shuttle because of the funding constraints delays that next vehicle, which keeps us from where we want to go in the future.
Well, with permission of the chair for a moment, the new vehicle does have a lot more flexibility and capability, but not in terms of the size of the payload. And so to the extent that some of these are payload size issues, the bottom line is that if Congress and the administration in the future decide that we need to have an extra mission or two and it needs to last an extra 6 months or two, that's kind of in our hands. There's no technical reason you're aware of or Mr. Holloway is aware of that's an impossibility.
No technical reason.
Thank you, Mr. Feeney. Thank you, Mr. Gerstenmaier. That's actually a very good point to keep in mind that Ranking Member Feeney mentioned. Dr. Neitzel, if I turn to your sobering testimony on both the status of and the outlook for the station research, if I could, I'd like to throw a few questions at you, and then you can pick and choose the order in which you'd answer those. But the first one would be, do you think the situation is irreversible, and could it be fixed? And I would then move to follow on, which is, if it isn't irreversible, what would be your highest priority recommendations for fixing it? And that would be, what could Congress do? And then as a follow-on to that question about Congress, what would the role of NASA and the administration be fixing a situation that, again, you point out is pretty sobering? So appreciate your thoughts on.
Well, the research community is down to next to nothing right now. There are a few non-exploration research projects sponsored in academic institutions. I'm fortunate enough to have one of them, a small one. I don't think the situation is irreversible at this time, but I think if we wait too much longer, it may become irreversible. As I pointed out in both my oral and written testimony, a large number of the people who were working on these NASA-related projects have now moved on to other pursuits. These people have lots of interests, and there are lots of other places to receive funding to support research and to support graduate students and undergraduate students. However, there are probably still some experiments that had been in the planning and development stages prior to the cancellation of these projects that may be able to be taken out of the closet, dusted off, and revitalized so that they could be flown perhaps as early as 2010. The problem is that a flight experiment used to take 7 or 8 years to get to space. With the development and the very wise decision by NASA, in my opinion, to develop these facility-class payloads, that development time for experiments that couldn't utilize those facility-class hardware payloads was going to be brought down to about 4 years. That's the length of time that a faculty member gets interested in now, because that's the length of time over which a PhD student is typically trained. So I still think there would be interest in a large fraction of the community that had been involved in NASA-related research to come back and continue with the research if their other commitments allow it. Your second question was, if it isn't possible, the highest priority for fixing. I think I sort of wrapped both of those answers into that. And the role of NASA is that NASA has to, and the government as a whole, has to commit to a long-term support of fundamental and applied research aboard the ISS in order to get this community back to the fold. No one's going to want to come back, revitalize a piece of research, start working again on a flight experiment, only to be told a year from now that the priorities have changed again and your work isn't needed. So I think there needs to be a long-term commitment to the science community to support research that will ultimately get done aboard the ISS.
Could you expound a little bit more on that length of that commitment and any more specific thoughts you might have about what that commitment would involve? This is from NASA.
Well, I believe you were out of the room when I responded to Mr. Rohrabacher that the community had come up with a keep alive number of about $70 million per year that would be required to sustain an effort, roughly half of what it was before the December 2005 Christmas letters that we received from NASA that canceled the research program. I think at a minimum that kind of a financial commitment needs to be made by NASA to ensure that there is enough community left with experiments in the pipeline to be able to effectively utilize the facilities aboard the ISS out until its projected lifetime ends. If we think about that pipeline requiring 3 or 4 years to get something to space, then experiments that are going to be done in 2010 had already better be started. And the ones that would start now would then go into the years beyond 2010, taking us out to 2015 or whenever the ISS ceases to be viable.
Yeah, I understand that Congressman Rohrabacher is open to further persuasion by the ranking member when it comes to investment.
That's good to hear.
That's well. I thank you, Dr. Neitzel, for your input and your insight. And I think this is a very important general point you've raised. Chair looks forward to working with you.
Thank you very much.
Used in all the ways we could. Chair would recognize the gentleman from Texas for 5 minutes.
Thank you, Mr. Chairman. Mr. Gerstenmaier, in Mr. Holloway's testimony, he states that the ISS Independent Safety Task Force recommended that NASA commit to carrying out 2 so-called contingency shuttle flights to ensure that the ISS will have the needed spares in place prior to the retirement of the shuttle. In fact, he states his view that NASA should, quote, develop an option that ensures that the 2 remaining shuttle exterior flights are given the highest priority for flight in front of Node 3 if necessary to avoid exacerbating a problem should all planned shuttle flights not be completed, unquote. Those are pretty forceful and unambiguous statements. Do you agree that the 2 contingency flights should become part of the baseline?
Yes, technically, I think that's something we need to fly those flights for the reasons we've discussed.
And then what about his personal recommendation that they be given the highest priority for flight?
Again, I think I would soften that a little bit just to see what our failure rate is over the next year, and I recognize we won't have perfect data, but I sure will have a lot better data after seeing how this hardware performs in 1 year, and then we'll make a decision on whether they're the highest priority as you described.
And then when will the final status of the 2 contingency flights be nailed down, and who needs to make the decision on whether to include them in the shuttle manifest?
They're currently in our budget right now, and we plan to seek to officially add them this summer.
Mr. Holloway and Ms. Chaplain, would you please comment on that line of questioning?
I don't have anything to add except I suspect when it plays out, those 2 flights will be critical in maintaining particularly the external spares. As you know, today there's not a capability outside the shuttle to launch external spares, and so NASA will be dependent upon the emerging Japanese capability or the COTS capability, and neither of those are a sure thing, at least in the short term. So again, I believe, as the task force recommended, that getting these 2 flights done is extremely important to maintain the viability of the station.
Chaplain?
I agree with Mr. Holloway, and would just add, though, that not having Node 3 goes up does further hamper the ability to conduct research on the station, so it's another trade-off that makes research more difficult to do, but it's a trade-off you have to make if you want to sustain the station.
Thank you very much. Mr. Chairman and Ranking Member, I for one, and probably people may start throwing things at me when I say this, but I think it'd be very, very worth our while to see if we can't begin to lobby our own colleagues to find the money necessary to do more of the science. Sure, it's going to cost us more money, but we chose to dream, and we chose to dream big, and now for us to back off on doesn't make a lot of sense to me. I'll put my neck on the line and go out and start asking for support for the increased resources necessary to do these things. Science is critically important. It should be more than $70 million, in my opinion. And when we begin to skimp, it just seems like we shortchange ourselves. We've gotten huge returns from what we've learned in the past, financial returns. We created significant industries. We've created untold numbers of jobs and put exceptionally great amounts of money into the economy. When we choose to look and play small, I think we give away our future. At any rate, I'm volunteering to work with you and any of the rest of us in Congress to try to make these things happen. Dream and tell us those dreams, and we have the responsibility to try to make them come true. I'll yield back my time.
Gentleman from Texas is always courageous and well-spoken, and I look forward to working with him to make sure we make the maximum usage of this leadership in that regard. The gentleman from Florida is recognized for 5 minutes.
Well, thanks, and I appreciate Congressman Lanson's encouragement and agree with that. I should know, my understanding is our Appropriations Committee in the House has put in plans the capability to fund the 2 contingency missions, which for the long-term health and resiliency and longevity of the shuttle apparently very important according to the task force recommendation. I don't think Mr. Gerstenmaier disagrees, and so I also think that having reestablished a regular schedule with some successes will make it easier for Congressman Lamson and Chairman and others to encourage our colleagues that a investment in future science programs. I mean, if you weren't going to get the shuttle back up safely on a regular basis, I can understand a lot of reticence. So the successes that we've had, Mr. Gerstenmaier, will allow us to make credible arguments along the lines Congressman Lamson suggested. I want to leave with one last thing that's obviously a passion of mine. We've got a huge workforce at NASA in the Kennedy Space Center area and with many contractors that service that area. We learned lessons after Apollo about the loss of workforce, but the transition after Apollo. We learned lessons after the Challenger disaster about the irreplaceability of the special capabilities and skills. Dr. Neitzel is testifying today about the problems in life sciences because we've dramatically slowed down emphasis in those areas. What does each of you recommend briefly that you can do as you complete the International Space Station and retire the shuttle that will make the transition for employees and workforce skills as seamless as possible?
From our perspective, we're trying to show that the work we're doing today has a real benefit to the future programs. As I described in some of my opening remarks, a lot of the systems on board Space Station that were up and operating, the pumps and systems that operate, are real systems that will be used in future exploration systems, and we have a natural tie between those two. So the folks that are working on Space Station can see that their future and their work is tied now, today, is tied to exploration in the future. Same with some of the workforce down at the Kennedy Space Center. We recently we're getting ready to stack the solid rocket motors for the October flight. And typically we stack those solid rocket motors in parallel. We stack one side and the other side into the 2 stacks that then the external tank will hang between. What we're doing this time is we're just stacking one of those boosters, and we're doing that because we're going to fly the Ares 1-X flight in 2009. That'll be the first test flight of the Ares system with the dummy upper stage with just a single booster off of one of our mobile launch platforms. So we're going to gain data on how much that launch platform deflects with just a single booster on it. We can provide that data to the exploration folks. So again, we're showing a real-world, tangible example of the shuttle workforce is actually preparing the way for the exploration workforce to get ready. So we're showing our workers there's a future. The jobs will be different. They may not be operational type of jobs. They may be more developmental operations kind, or more They will not be operational jobs. They will be more developmental in nature, but we're showing that there's a future. We're providing them training opportunities and allowing them to be part of that future system today while they're doing their existing job.
Go ahead, Ms. Chaplain, or anybody else who would like to, and then I'm going to yield back to balance my time when the panel's completed.
I just would make a couple comments on workforce because we've been doing some work in this area. One of the things we would like to see NASA do is make sure it has good measures to track the progress of a lot of the actions they've been taking to sustain and keep the critical skills that they need. The activity of mapping skills that they have now to what they need in the future is good, but that needs to be tracked continually. And government-wide, you know, we have this issue of retaining systems engineers in-house in government agencies, that all agencies are, you know, facing problems in that area and incentivizing people to stay. And at the same time, knowing how to manage the contractors that you're relying on to conduct activities in systems engineering. So it's just another area they need to pay special attention to and to make sure they don't lose that critical expertise.
May I make a comment? I certainly would worry about the ability to retain center personnel at the various NASA research centers who work in support of the research payloads that go up to the station and have been flown on the shuttle. There's a large body of expertise there that could conceivably be lost. As you pointed out, in the era between Apollo and the shuttle program, a large amount of institutional memory went away. I also worry very much about our ability to motivate future generations of young Americans to consider careers in science, technology, engineering, and mathematics, the STEM disciplines. We have a hard time right now retaining young people in universities who come starting to study engineering and sciences. So we need motivators to keep those kids interested and to keep them wanting to pursue careers in science and engineering. And if we take away a large thing like the space program, which is one of the things that motivated me when I was a teenager growing up in Florida, we risk losing the next generation to these kinds of activities. Not the whole generation just because the ISS may go away, but we really need these kinds of things to help motivate our kids to pursue careers in technological fields.
I thank the gentleman from Florida for some terrific questions. I'm going to direct a final set of questions to Mr. Gerstenmaier. My favorite assets in the portfolio of NASA, and that's the Hubble telescope. I'd like to give you, Mr. Gerstenmaier, a chance to talk a little bit about the status of the preparations for the mission and what do you consider to be the greatest challenges completing that mission successfully. And is there any chance that the 08 launch date slip because of needs to accommodate a assembly mission to the station?
We're actively in the process of working on that mission with the Science Mission Directorate, and the Science Mission Directorate is finalizing the activities that are going to occur on that flight, what specific instruments are going to be repaired. We've been busily working with them to ensure that we're prepared to go do this. Again, Space Station has prepared us in a lot of ways that we were not prepared with before for the Hubble servicing mission. We've gained a lot of experience in extravehicular activities or spacewalks that'll have direct application. So I think the teams are prepared. We're ready for that mission. Recently, when we had the hail damage to the tank, the shuttle manifest went through a slip. We actually held the Hubble mission in its position in the calendar dates, and we let some of the station missions slide beyond the Hubble mission to hold it in the September time frame. I think on paper we show it now maybe in the August time frame. It'll probably be in September when we actually fly the mission. So we've been able to hold the Hubble telescope even though we had some schedule threats and we let the station flight slip around because, again, we don't often get to optimize for whatever situation we have. We have to balance between the two. So we balance the risk of getting the Hubble serviced at the right time against the station delays, and we made the appropriate decision, I believe, to hold the Hubble where it was. So again, things look pretty good for the Hubble mission. One other thing I'd add is the Hubble telescope team is looking at some innovative tools to actually be able to repair potentially some devices out on the outside. They've developed a device that will hold screws that allow us to essentially pop a circuit breaker out of a device that's on the outside of the Hubble Space Telescope and replace a card within that computer device. I don't know if we'll decide to do that particular task on the Hubble mission or not, but that has tremendous application to space station and other vehicles. We now maybe have the ability to go outside and repair a computer box without having to bring it inside, pop the card out, put a new card in. We may be actually able to do that on the outside. So again, we're able to learn from the science group and what they're repairing for their repair mission and apply that to station and apply that to exploration. So as long as we stay open and we continue to work across programs, we can maximize the benefit as we move forward. So this mission fits well.
Just out of curiosity, since I have a little bit of time left, the procedure you just outlined, in the past, has it been difficult or impossible to undertake because of zero gravity or because of the extreme conditions that you find outside the body of the space station or the telescope?
The problem in this case is there's a bunch of screws, about I think maybe 10 or so screws that actually hold the circuit board in place. Those screws are not captive. So when you're in the spacesuit with the gloves and the tools, and you back that screw out, it typically floats away, and then you're in not such good shape. What they've developed is a simple plastic device that sits over the top of those screws, and then as the screw backs out with the device, it goes in and it's held captive in this plastic device, and then you can change the card out, put the plastic device back on, screws back into the circuit board. So it's a clever concept, a mechanical way to capture and hold these screws, or a way to repair something that wasn't intended to be repaired that way. And I guarantee you we will take benefit of that on board Space Station, either on the inside or on the outside of Space Station.
It also has usefulness in a gravity environment as well.
It's not as critical in the gravity environment because gravity provides that force that holds the device or the screw where you want it to be. In this case, it's a mechanical.
Mr. Chairman, just out of interest, if I may, sorry to interrupt, but I'm going to show my scientific ignorance here. That's why I was a dirt lawyer before I got to Congress. Wouldn't magnetic capabilities help?
That would be another option too, but the beauty of this device is you place it on and then all 10 screws are held by this device, where some kind of magnetic capability, it may be a screw at a time, and then you've got the screw magnetically held to your screwdriver, and then how do you get it off with this big glove on? This way it's all held by the mechanical device, and it's a very elegant solution to a fairly simple problem, but a problem that we face in zero gravity.
I thank the gentleman from Florida for his question. At this point, I want to bring the hearing to a close. I want to thank all of the witnesses for testifying before the subcommittee today on these very important topics that deal with the future of the space program, our competitiveness agenda, and whether we're going to be the innovator of the world in this regard. If there's no objection, the record will remain open for additional statements from the members, and for answers to any follow-up questions the subcommittee may ask of the witnesses. Without objection, so ordered. The hearing is now adjourned.